This is Module 1, Lesson 5. We're looking at dimensional analysis, factor label method, or converting between units. However you want to say it, we're changing units from one thing to something else. How we're going to do that is by using conversions, or conversion factors. What they are is just two things that are equal to each other. So, for example, I wrote 5 of them down here. 1 inch is equal to 2.54 centimeters, so I made a fraction out of it. A foot is 12 inches. And then on this one, I flipped them. Put the 12 inches on top and a foot on the bottom, because if they're equal to each other, you can flip any of these and write them two different ways. 1 hour is 60 seconds. $1 is 10 dimes. We can turn any two equal things into a fraction by putting one of them in the numerator, one of them in the denominator, and boom, we have a conversion factor. What we're going to do with those is called dimensional analysis. It's a way to multiply by conversion factors to manipulate your units into something else that you want. I kind of have a step for you right here that helps you as you go, that whatever unit is in the numerator will go in the denominator of the next fraction. It helps us link things together to know what comes next. We're always going to start with what we know, and we're just going to repeat the same process again and again until we get what we desire. So use the power of video as we go. I know that this is confusing to begin with. So use the power of video to rewatch things, pause it, back up, skip ahead. You know, some people may need to watch the same problem several times before the light bulb goes off and they have their aha moment. So with this one, we're going to start with converting 3.65 kilograms to milligrams. This right here is what I know. So that's what I'm going to start with. 3.65 kilograms. And we're going to put that over an understood 1. I'm going to let this yellow line be my fraction bar to just keep me a little straighter as we go for some of these. Okay? What we're going to do next is we're going to multiply by another fraction. So if this is a fraction right here, we're going to do another one right here. What needs to go in the bottom is kilograms, because remember with fractions, we multiply across the top and then we multiply across the bottom, and anything that is alike on the top and the bottom will cancel out. That means these already cancel if I put kilograms down here. We are not cross multiplying, we are multiplying fractions. Now I need to put something in the top that relates to kilograms. Back when we did our metric prefixes, I had you memorize these based on the base unit. That kilo means like 1,000 grams. 1,000, like the base unit for this is the gram part of it. So a kilogram is 1,000 grams. So what needs to go on top is gram. I did not memorize kilo compared to milli. So what I just said was a kilogram is 1,000 grams. I don't know why I started with a 0, but I didn't. Okay, so 1 kilogram is 1,000 grams. If I stop right now, my answer will be in grams, and that's not what I want. It asks for milligrams. So I need to multiply again. Grams needs to go on the bottom this time. Why? So that they cancel out. And I do know the meaning of milligram compared to gram. A milligram is 1,000th of a gram, or 10 to the negative third. So what that means is that it will take 1,000 of those to make up a gram. So now if I stop, it's what I want. I can stop and do math. And if you put this in your calculator, or you can do it in your head, you will get 3.65 times 10 to the 6th. I do not want to have to count decimal places. I would prefer this to be in scientific notation. And we're going to put a unit on there with it. We've got milligram, okay? So if I stop right now, here's my answer. Now in terms of Sig Figs, I'm going to keep this with the original Sig Figs. When we're looking at Sig Figs, we're just going back to this piece right here, because all of these are defined quantities. They all have an infinite number of Sig Figs. This has 3 Sig Figs, this has infinity, and this has infinity. That looks like an 8, but it's infinity, infinity, 3. 3 is smallest, so I get to keep my original 3. Anytime we're doing these, you're always looking at your original numbers. You're pretty much not going to change anything. Okay? So here, let's do another one. How many nanograms are in 3.5 kilograms? Start with your given again. 3.5 kilograms. I'm going to put an understood 1 on the bottom, and we're going to multiply. Now this time I'll show you a little bit differently how we can do the table. I'm going to put kilograms on the bottom because I need it to cancel out. And again, we're going to go to the base unit. 1 kilogram is 1,000 grams. All right, these cancel. I can't stop because this is not what it's asking for. I need to multiply again. grams needs to go on the bottom so that they cancel. And I know grams compared to nanograms. A nanogram is a trillionth of a gram. So what that means is that it will take a trillion, there's a million, billion, trillion, it'll take a trillion of those to make up a whole gram, a trillion trillionths. So when you put this in your calculator, or you can do the math on your own, that'll be 3.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3.5 times 10 to the 15th nanograms. We went back to our original Sig Figs here, which was 2. We kept 2 there. Now, something that I usually do is I don't usually write it exactly like this. I usually will put my fraction bar, and then I just go on across and I draw a line. I don't do the multiplication symbol. And then when I get to this step, I'll go on over and I'll draw a line. It's very common to see the lines. I'm going to work the next one just with the lines to show you what I mean. It's the same process. What we're doing is we're just multiplying. And that is acceptable in AP classes as well as college classes when you get there. Okay, this one. It says, how many grams of water will fit in a 5.5 liter fish tank? Well, one of the things that you're going to need several times in this class is this handy bit of information. This is for water only. Water has a density of 1 gram per milliliter. You know, you'll usually see it written oftentimes like this, but that can be written on top and bottom, like 1 gram per milliliter, and that's an understood 1. And if that's the case, I should see this and start thinking conversion factor. I can flip that and I can write it as a gram, or I can write it as a gram over a milliliter. It's a true statement either way if water is 1 gram per 1 milliliter. Okay, what that's going to do is that's going to let me tie together the grams with the liters. So the first thing that I'm going to do is I'm going to put my 5.5 liters, I'm going to put it over an understood 1, and now I'm just going to make the table. Instead of putting the multiplication sign, which is understood to be right here, I'm just going to put the bar and I'm going to keep going. Liters is going to go on the bottom, and I've got to get to milliliters before I can get to grams. So 1 liter is 1,000 milliliters, because milli means thousandth. It takes 1,000 thousandths to make up a liter. That cancels, and now I've got milliliters. My next step, whatever's up here, has to go in the bottom of the next fraction. And I can compare milliliters to grams because of this. Water is 1 gram per 1 milliliter. Those cancel out, and now I can do my math. I'm at what it asked me, how many grams. I'm there. I've canceled everything out. I can do my math. So 5.5 times 1,000 is going to be 5,500. My unit that's left is gram. So there's my answer. I could also write it as 5.5 times 10 to the third grams. Those are equal to each other. We have the correct number of Sig Figs. It was 2 to start with, 2 and 2. So, hey, I'm good to go. Okay, one last problem. All right, so this one is about converting from like cubic meters to centimeters cubed. And I want to point out something to you when we do these. So a lot of students have some confusion about these. The very first thing that I need to do is I need to calculate this. I actually need to do the math for this part and see what it equals. And I've already done that. If you multiply length times width times height, this comes out to be 2.16, and that will be cubic meters. So this is what we're going to start with. This is our starting information, 2.16 meters cubed. So we put it over an understood 1, and then we're going to multiply from there. Now, first thing I need to do is I need to get from meters to centimeters. This is a basic step. Centi means 100th, so it's 100 centimeters to make up 1 meter. But now, if you're thinking about this at all, this is cubed and this is not. So in order for these to cancel out, I need to cube it. So it's a very simple fix. I'm going to take this and I need to cube the whole thing. If I cube the whole thing, if I write this out for you so that you can see it, come to fruition, this would be this over 1, and if we cube it, then this would be 100 cubed, centimeters would be cubed, 1 cubed is just going to be 1, and then this would be cubed. Now it's meters cubed and centimeters cubed, and that's all that you have to do. The mistake that most of my students want to make is right here. They don't want to cube it. They think that you can just simply do 100 centimeters over 1, and you can't, because if you stop and you think about it, if you have a box, it's a cube, if it's a meter on every side for the length, the width, and the height, then in terms of centimeters, it's not equal. This is 100 centimeters and 100 centimeters and another 100 centimeters. So when you do 1 times 1 times 1 for meters cubed, that's 100 times 100 centimeters cubed, which is why this works out right here. Now, from there, your answer is going to be 2.16 times 10 to the, let's see, that'll be 6, so 6. 2.16 times 10 to the 6 cubic centimeters, okay? And I would, again, prefer that answers that are that large not be written with all of those digits. I don't want to have to sit here and count out the number of decimal places. So this has been super fast. We have one more problem here to show you with some different numbers. So it asks you to convert grams of aluminum. Now, a lot of my students get confused by this because they see two different numbers. Here's the question, though. How many milliliters of aluminum are in this many grams? This info is here so that I can do the problem, but down here underlined is the question. So I'm going to set the 4.6 grams over an understood 1. We know that grams has to go in the bottom of the next fraction, and this right here allows me to relate grams and milliliters. It's asking me for how many milliliters. I can put the milliliters up here. Now this, if you write this out, it is 0.897 grams per milliliter. This is what it would look like. So down here, what I need to do is I need to flip it. The 1 milliliter needs to go on top, and the 0.897 grams needs to go on the bottom. Now, I have students who seem to get confused at this point and they want to cross multiply. You can't do that, it's a fraction. You are multiplying across the top, and quite frankly, if you need to do this in 2 steps, like I did, you can. Grams is canceled, so it's 4.6 milliliters divided by 0.897. You will get 5.1282 and a bunch more digits. So what do we do with this? We look at, again, our original number for Sig Figs. There's 2 Sig Figs here. I get to keep those 2. So that's going to be 5.1 milliliters. That's my unit that's left over. Here's the answer to this question. So this one was a little bit different. I tried to give you a variety of problems for some examples. What I want you to do is I want you to go to the practice part of this, and I want you to try the problems. If you get stuck, what would help me to help you is if you can take a picture of what you do have set up and send it to me. You can send it to me through Canvas, or you can send it to me through email, or you can wait and join me during office hours, and you can show me your work so that I can tell how to help you from there. If I need to work more problems for you, then you need to be asking for some more examples. I will also include some YouTube links in the extra help section in case you would like to watch some other people or older videos of mine. Now it's time to see what made sense. Rewatch it if you need to.